Hello viewers, you are welcome to another section of Knowledge is Power. I'm still on the partial derivative, but today I'll be using the product rule to solve a partial derivative problem. In the previous classes I used the power rule. The product rule, it's a little bit complex compared to the power rule, but I'll be giving you detailed steps on how to use that to solve a partial derivative problem. Let's see what the question is asking us to do. I say that we should find the partial derivative with respect to x. In that case, y is constant. Y is constant. Okay. If y is constant, we're dealing with just x. Good. And when using the product rule, it's very important you use other variable apart from the x and y, which is in this function, to represent your product. First, let's know how many product we have in this question. So just underline. So if you look at it carefully, we discover that we have two products. This is the first one, or let's say this is the second one, and this is the first one from the left-hand side. So I can just level it and say P1 and say this is P2 to make the whole um, work easier. So in that case, it means that we're going to find a derivative with respect to x in P1. That's in respect to x with P1. And also in P2. So to do that, let me use U and V to represent my product here, which is a P1 and P2. So let me say U is equals to E negative exponential x to the power 2 plus y to the power 2. That's my first product. And the second product, V, is sine x y to the power 2, first and second product. So in that case, let me use this formula. Let's say function, partial derivative function for x. So partial derivative for product 1. Let me say partial derivative for product 1, which is a ux. Okay, let me just write it somewhere here. Ux for the partial derivative for product 1 with respect to x, and also vx uh, for product sorry for product 2 with respect to x. So and v plus u multiplied by v with respect to x for the product 2. So when we look at this formula here, we can see its formula. We discover that V is known because we have it here as P2. And U is known also. We have it here as P1. So what we're looking for is the first um, partial derivative for product 1, and also the partial derivative for product 2, P1 and P2. So that's what we're looking for. So let me say, okay, u x, which is the partial derivative for product 1. Here we have it as e exponential x to the power 2 plus y to the power 2, y to the power 2. And the question says with respect to x, which means y remains constant. So y remains constant. So let me just bring out this x to the power 2. And remember, there's a negative sign here in front of this x to the power 2. So it goes together. Let me just bring it somewhere here. Negative x to the power 2, which is the same thing as 2x, negative 2x to the power of 2 minus 1 equals to 1, and that is a 2x negative 2x to negative 2x. So the first partial derivative for the product 1 is e negative exponential x to the power 2 plus y to the power 2 with a multiplier negative 2 negative 2x. So let's go for the partial derivative for p2, which is vx, and that is sine x y to the power 2. And let me just bring the sign here. Whenever you see sine, always find the derivative for sine. And the derivative for sine is a sine x. Sine x, it's equals to cos x. So have this at the back of your mind. Whenever you see sine in a derivative, partial derivative problem, so the derivative of sine is a cosine. So in that case, this sign here, let me just, okay, this sign here will become cosine. Cosine. So now we're interested in x. And remember, this y to the power 2 is a multiplier with the x, but it remains constant. So let me just bring this x somewhere here, which is x, um, same thing as 1x to the power 1 minus 1, which is 0, and that is the x to the power 0. And remember, anything that is to the power 0 is equals to 1. Anything that is to the power 0 is equals to 1. Good. So anything to the power 0 is equals to 1. We'll do this a little bit. Okay. Good. So anything to the power 0 is equals to 1. So, and remember, this this y to the power 2 is a multiplier of x, so we just say multiply by y to the power 2, which is equals to y to the power 2. So we can just, so already we'll find the derivative of sine and also the derivative of x. Good. So in that case, our vx, or the partial derivative with respect to x in product 2, is equals to y to the power 2, close it, cos yx to the power 2, this here. So let me just, so let's just substitute all this into this formulas in here, into this formula here. So, which means our function is equals to um, the derivative for product 2, which is e exponential negative x to the power 2 plus y to the power 2 with the multiplier of negative 2x plus plus v, which is sine x y to the power 2, sorry, multiply not plus, then plus the first product d1, which is exponential negative x to the power 2 plus y to the power 2 multiply by vx, which is derivative for the product 2, and that is y to the power 2 cos um, x y to the power 2. So when we look at this function, we know there is something that is common here. So this and this, they are common. So what we have to do, the common factor in this function. So we say that fx equals to e to the power negative x to the power 2 and y to the power 2 So we have negative 2 x sine x to the power x y to the power 2 plus y to the power 2 cos x y to the power 2. So this is what we are asked to find here. That is the partial derivative with respect to x.